All right, hello. Today we are looking at our first day of multiplying fractions and whole numbers. Before we get started with actual fractions, I want us to look at an example so we can actually see some of the strategies that we can use in a familiar setting, and that setting is going to be with whole numbers. What I want you to do right now is pause and draw a picture that you could use to solve the following problem, and then write a number sentence for the problem. And the problem is Riley wants to give 5 cookies to each of her 3 friends, and we want to figure out how many cookies she would need. If we draw our picture, what we're doing is we know that she has 5 cookies to each of her 3 friends. I'm going to draw out a plate for each of her 3 friends, and then each friend is going to get 5 cookies. So what we're looking at here in this problem is now 3 groups of 5, which as a mathematical sentence is 3 times 5, which gives us 5, 10, or 15 cookies. I want you to really pay attention to the way that I wrote this. So when we're looking at a problem like this, the first number is always going to tell us the number of groups, and the second number is going to tell us how many are in each group. So in this case, 3 groups of 5 becomes 3 times 5. Which leads us down to the second example. So in 2 times 4, what would each number represent? Well, 2 would be the number of groups, and 4 would tell us that there'd be 8 in each group. So now that you've looked at that problem, or an example using whole numbers, which you would be familiar with, let's look at another one. I want you to pause the video and draw a picture that you could use to solve the following problem, just like we did in the previous one, and then figure out a number sentence and solve the problem. In this problem, Seth wants to give each of his 4 friends 2/5 of a pizza. So we know he has 4 friends, and they're each getting 2/5 of a pizza. How much pizza would he give away? Since we know Seth has 4 friends, I'm going to draw out their 4 pizzas. Since each friend is getting 2/5 of a pizza, I'm now going to take each pizza and split it into 5 parts. Since each friend gets 2/5, I'm going to shade in. Two-fifths of each pizza. In our problem now, we have 4 groups, and each group is 2/5. So our problem becomes 4 times 2/5. While in the end, we have only fifths left, and I can start to count. Here I have 2, 4, 6, and 8. So in the end, I have 8/5 of a pizza. Or what I can start to do is these 2 become those. Then I take 1 from here, and that fills in 1 pizza. And now I have 1, 2, 3/5 left. Or in other words, I have 1 full pizza and 3/5 of another. So this problem is similar to our last one because we can draw out pictures to represent what we have, and we have groups, and in each group there is something there, and we can use that to then solve our problems. Now what I want you to do independently is to pause the video and figure out the answer for each one of these problems. I would encourage you to start with using pictures, and then go to words, and then go to a number sentence. So our first one is 5 times 1/3. I'm going to draw out my picture first. Each picture gets 1/3. So I'm looking at 5 groups of 1/3, which is going to be the same as 5 times 1/3. And I can start to count 1/3, 2/3, 3/3 makes a whole. And then I have 2/3 left over, so I have 1 and 2/3 as my answer. Our second problem. And 7ths I always find are tough to draw, so I'm going to kind of bear with me here. And each one is going to have 2 7s shaded in. So in this problem, we have 3 groups of 2 7s, which becomes 3 times 2 7s. In the end, we still have 7s. Since there's 3 groups of 2 then, we have 6 7s, so 6 7s would be our answer. One last thing I want us to look at is just 2 different examples. So this would be problem 1, and this is going to be problem 2. I want you to pause the video and just ask yourself, what would be a multiplication sentence and an addition sentence I could write for each problem below, if it's appropriate. Hopefully you notice in this first problem that it's similar to what we've been doing. We have in our problem 3 equal groups, and each of those groups would be 2/3 of a circle. So we could write that as 3 times 2/3, or we could write it as 2/3 plus 2/3 plus 2/3. Any of those ways that it's written, it would give us 6/3, which would be equal to 2. On the second one, we don't have equal size groups. We have one group that's a half and one group that's a fourth. So we could say 1/2 plus 1/4. We could even break up that half and make it into 2/4. But there is no way that we could write that problem with the way that it's drawn as a multiplication problem because we have different sized groups. So in this one, we couldn't write a multiplication problem, but only an addition problem, and it would be 3/4.